Hi, my name is Dol.
And hi, my name is Nick.
Today, we'll tell you guys a story.
Stay tuned, guys.
Ladang Pak Abu Agro Park. Ladang Pak Abu Agro Park is located at Hajah Rokiah Tiang Lampu 37, Jalan Kampung Parit Gantung, 83,000 Batu Pahat, Johor. This is Pak Abu and Puan Zima, a charming and hardworking couple, are the proud owners of a cow farm nestled in the serene countryside of Batu Pahat, where they dedicate their weekend to raising healthy cattle and contributing to the local agricultural community.
At the Ladang Pak Abu Agro Park, first they raise their own cattle, ensuring they are healthy and well nourished to produce high quality meat. Once the cattle are fully grown, they proceed to the next step, which is the slaughter process. They are slaughtered in a human and regulated manner. After slaughter, the meat undergoes a third process, which is an aging process. This can enhances its tenderness and flavor. Final step, the aged meat is butchered into specific cuts, making it ready for distribution, sale, or consumption.
So, what is actually the difference or the unique characteristic of this farm? The uniqueness of this cow farm is the owner grow their own napier grass. The napier grass is used for the food source for the cattle because it is high protein diet, and also the napier grass can protect the soil quality. This is an example of the napier grass that has been cut for about 1 week. Beside that, this is also an example of the napier fresh cut that have been dried and mixed with a few substance such as palm kernel pellet, corn silage, molasses, and also salt. What is the issue? What is the difficulty that the owner have to face? What is actually the problem at the Ladang Pak Abu Agro Park? The problem is the field boundary. Field boundary refer to the physical or construction limit that define the edge of a field, typically in the agriculture or land management context. During the monsoon season from October until December, especially at Batu Pahat, heavy rainfall often causes the field boundaries to overflow, leaving the napier grass waterlogged and prone to spoil.
And if that happens, it means no napier grass, no food stock, and also no happy cow.
Hi, Assalamualaikum and greetings. My name is Abdullah from Group Smart Agriculture 12, SA12. Our group do real-time water level detection for our integrated design project. Our team consists of 5 members, which are myself, Abdullah bin Abdurrahman, as manager, then Nik Filza binti W. Baharudin as assistant manager, then Wong Karshan as chief engineer. Then Muhammad Riz Hakim bin Muhammad Firdausi as engineer, and last but not least, Sharifah Akila binti Said Ahmad Tarmizi as assistant engineer. Real-time water level detection is a hardware-based solution designed to detect rising water level using an ultrasonic sensor. When the water reaches a critical level, the sensor triggers an alert that is sent to mobile application on the user's phone. The system uses Wi-Fi for connectivity between the sensor and the application, ensuring real-time updates and quick response. This project aims to provide an efficient and user-friendly way to monitor water level and prevent potential risks such as flooding.
At the 14th October 2024, we have our first meet with our group mate, discussing about the project regarding smart agriculture. And 17th October, we have our first discussion with our supervisor, which is Dr. Chia. He advised us to go any farm nearby, asking for any problem that occur in agriculture field. At 27 October, we went to Ladang Pak Abu Agro Park located at Batu Pahat. We get to know Pak Abu and his wife, Puan Zima. At 14 November 2024, we proposed our solution to Dr. Chia, told him about the problem that the farmer had to face in his farm. And at 29 November, We revisit the Ladang Pak Abu agro farm and told him about our solution for one of his problem that we choose.
Hi, my name is Sharifah Akila binti Said Ahmad Tarmizi and my matric number is CE210081. So today I'm going to present about our problem statement for our project. So the first problem statement is manual checks. Basically right now, people have to check water levels by hand, which takes a lot of time, and this means they might not notice when the water levels gets too high until it's too late. And manual water level checks are also time consuming, and also it do not provide immediate alerts for critical situations. And the second one of our problem statement is lack of alerts. If there is a sudden rise in water levels, there are no quick alerts to warn people about the danger. So rising water levels often go unnoticed due to the lack of real-time monitoring system, and it will increase the risk of flooding. And last but not least is about the poor connectivity. So the system that do exist often can't send instant messages to people's phones, so they miss important updates. Existing system lack reliable connectivity to send instant notifications to users via mobile application. And I think that's it from me. Thank you.
So, for this project, we have three main objectives. The first one is to design water level sensor that accurately detect changes in water levels and triggers an alert when critical levels are reached. So, the second one is to develop a mobile application that receives real-time notification from the water sensor. Okay, so the last one is to implement the reliable connectivity using either Wi-Fi or Bluetooth to ensure seamless communication between the water sensor and the mobile application. So for the hardware design, we make it the shape of U upside down. So we hang it the circuit in a box in the center with the ultrasonic sensor hang on it too. So now we move to the part methodology. So in this project, we mainly use two software. There is Arduino IDE and also the Blink. Okay, so the Arduino is the microcontroller that control the whole process for the water level sensor, which is the most important part in this project. Okay, so the next one is Blink that is used to connect it to the web server, a web server that will give us the real-time notification when and the critical levels are reached. Okay, so this is the circuit diagram which we use the ESP32 for its Wi-Fi module. Okay, then we have three LED, red, yellow, and green. We also have three resistor to connect it to the LED. And the last one is we have the ultrasonic sensor.
This flowchart is demonstrate how ESP32 process distance and respond with the specific indicators and alert based on the measure range. For the flowchart, we have the start, which is the begin, and then it will go through the ESP32, which is the process begin, and then we have the distance category, which is if the object is below 10 cm, the indicator 1 is activate, and if the object is between 10 cm to 30 cm, the indicator 2 will activate, and the last one is if the object is over 30 cm, indicator 3 is activate and alert notification is sent. So the notification will display the alert on the mobile phone, and then at the end of the process. Conclusion, at the end of the year of October until December, Johor, especially Batu Pahat, is one of the places that will face heavy rain. After visiting one of the cow farm that produce own cow food from the scratch napier grass, the farmer had a problem when facing the heavy rain. The grass will be spoiled due to the overflow of the water, and the owner will be having problems of feeding their cows. a real-time water level detection, monitoring, able to provide accurately, timely and efficient tracking of water levels. The system enhanced early warning capabilities, resources management and also decision making the process.